All right, this is stuff that you probably, this is stuff that you ought to, come on, Nick. This is stuff you ought to know by now. And so you've got Ohm's law mastered, right? Who can give me it?
1 ohm pushes through 1 amp, which pushes through 1 volt.
Yeah, 1 volt pushes 1 amp through 1 ohm. 1 volt pushes 1 amp through 1 ohm. 1 volt pushes 1 amp through 1 ohm. You got that?
Pushes
That
1 amp
picture that
through
you
1
showed
volt.
us yesterday.
Yeah, that picture. Yeah, the picture of it was this little drawing of this little fat guy pushing another fat guy through a pipe, and there was a guy sitting on top of the pipe trying to pinch it shut. And the guy sitting on top of the pipe was ohms, and the guy pushing was volts, and the guy trying to be pushed through was amps, right? Now that's a sort of, that was actually one of my graduates is up at a manufacturer school where they're teaching him electrical stuff, and that was one of the first little drawings that they threw out there. I thought that was interesting. And he was telling me, he sent me a text today, and he says, you must be in cahoots with this guy up here at this factory school because he's using training aids like the ones that you built. And I said, that's because I went to that same school whenever I was at a dealership, and I saw those things, and that's where I got the ideas for mine. But he said the difference is these are for dummies, and the ones that you make are a little more complicated. But anyway, basically what you got here for power, if you do current times volts, you'll get 10 watts, right? On that. All right, so you got to start with a solid mastery of the fundamentals. If you can master electrical fundamentals, you'll eventually be able to fix stuff that other people can't. Now, Kayla and I got our heads wrapped around this S10 because the schematic was running off of one page onto another one, and it had a relay on the ground side of the headlights and another relay on the hot side of the red. So it had grounding relays and hot relays. And we were scratching our heads trying to figure it out. And what we found was, you remember how we located the problem with those headlights on that S10? We got to that. We went to the multifunction switch, and we found out that there was a ground, because the ground was going through the multifunction switch, not the power on that one, as I remember. Now I've slept since then. But anyway, one way or another, what was needed wasn't going through the switch, and we worked on that and figured out that the wire colors were different between the connector and the switch than they were at the other. Anyway, it was a bear. Well, you got to have how to test and how to interpret the test, and voltage is going to be defined as electrical pressure, basically. That's why you have to juice up the ignition coil. The 12 volts has got to go up to 100,000 to jump across the spark plug gap when there's pressure in that cylinder. Voltage can be defined that way. It's necessary for current flow. Where there's no voltage, there's no flow. So variable voltage should be tested first. So you got to be able to, when you're starting any kind of an electrical diagnosis, and a lot of the times when you're doing engine performance diagnosis, the first thing you need to know is, do I have a good strong battery? Do I or not? Right? Now, does anybody remember what I told you could do to determine if the battery was matched to the car? And I'm not talking, huh?
You just spin the start for 15 seconds and then it drop below 9.6.
Yeah, so you're basically you disable your fuel system. And the reason you disable your fuel system is you don't want the injector squirting fuel in there. Even if you disable your ignition, if your injectors are squirting fuel in there, you'll wet the spark plugs. So it's better not to do that. So disable the fuel system and get it to where it won't start at all, and spin it for 15 seconds. And if it doesn't go below 9.6 in 15 seconds, that battery's okay for that car. Now if you take a battery and look at the cold cranking amps. All right, let me ask you this: if I'm load testing a battery, how much of a load am I supposed to be putting on it for 15 seconds to load test the battery? What's the rule for that? You remember? Remember from your electude? Anybody got that? Half your cold cranking amps. If the cold cranking amp is 500, you're going to put it at half a cold cranking amp for 15 seconds and make sure it doesn't go below 9.6 volts. If it does, the battery is weak. Of course, you got to have the battery fully charged to do this. And even if a battery is fully charged, that doesn't mean, a battery's like a gas tank. The older it gets, the weaker it gets. And it gets to where it's got less and less and less cold cranking amps. But see, a battery that might start a car with a big engine, big hard to turn engine, might have trouble starting that, would start a 4-cylinder like Nick's little Versa or whatever, it's real easy. All right, voltage only the command. Amperage, color that current flow, does the work. Resistance restricts amperage, and that reduces the amount of work that can be done in the system. So resistance creates heat, right? In connectors and wires. They start to get a little chalky, start to get a little oxidized, they're gonna get hot, and they're gonna burn up. And whenever the hotter they get, the more resistance they get, whenever they start to get oxidized and chalky. And the more resistance they get, the hotter they get, and finally everything breaks down and current quits flowing, and it looks like that. That's a headlight switch connector right there. I got some right over in that bucket that look just that bad. When diagnosing computer-related circuits, realize computers communicate only voltage, not in amperage. So if you're looking at a throttle position sensor, you're not measuring amps, you're basically measuring just a change in voltage. And they're gonna have a voltage dropping resistor. If I take, and I put my hand on a positive battery terminal, and you hook a meter to a negative battery terminal, and I'm holding that positive battery terminal in my hand with my fingers, what you gonna read on the meter? 12 volts. Did you know that? Going through my body, you'll see 12 volts on that meter. I can show you that, but I'm not going to take the time to do it. Not right here. But the long and the short of it is, that voltage will pass through my body, and all the computer needs to see is that voltage. And it knows what to do. It's basically like an input thing. All right, with an analog speed sensor pin, read and flip back and forth between speed values. The computer connector looks normal, you have a bad analog to digital converter. So basically, inside the computer, this is an analog signal, and it basically uses little algorithms and thresholds to change that into a digital signal, because computers don't like analog signals. They really don't. They'd rather be digital. Cam crank vehicle speed sensors usually have an analog voltage, and you need to know the sensor's frequency, pattern, and signature, or what it uses to determine the spinning shaft speed and position. The triggering and slope come to play when the ECU is interpreting a signal. I said this before, but I can take these two wires right here, go to pins 21 and 22 on this thing right here, and I could swap those two pins around, and that vehicle would never start, because the computer, you usually look at your scan tool, it'd count up to like 200 RPM and then drop to nothing as soon as you're spinning it, and you never get spark, because it's looking at that waveform and it's sensitive enough to where it knows when it's upside down. Computer output signals are always digital. That means on or off. PCM sends digital triggers in a bunch of different ways. Pulse width modulation, as with injectors, have a spike when the current shut off. Now, on that little Consulab board, did you guys see that little pulse width generator? Did you all wire that up so that when you dialed it up and down, the light would get brighter and dimmer? You know, if you look at the way it operates, you feel like you're using something like a rheostat. Now, computer output signals or something you're going to be dealing with. That 10% duty cycle means it's on 10% of the time. 50% means it's on half percent of the time. 90% means it's on 90% of the time. And there's your line right there. You got that? So understand pulse width modulation, the duty cycle, and all. Computer output signals are really important to understand. Now, frequency is the speed at which the cycle is repeating, and hertz is how many times per second the cycle is occurring. I used to work on these airbag systems on these Lincoln back in '84, and they would say whenever you grounded this wire to open and close the door, the airbag light would, I'm talking about the one for the suspension, would blink on and off at 1.8 hertz. What's that? Almost 2 times a second, right? Hertz is how many times per second. Now you gotta take stored captures and share them with other mechanics online. If you want to be, there's a website, there's a Facebook page I'm on where where the mechanics will share their patterns, you know, their picoscope patterns and all, picoscope. Kirchhoff law, you gonna remember this? You gonna remember it when you see it on the test? There's gonna be a test about this. You gonna remember it? Remember it. Burn it in. It refers to the fact that this is a simple version of it, that voltage drops across a load, and the load is basically anything that has resistance and does work. Loads have resistance and turn current to heat, light, movement, and all that. Bad connections have resistance. So basically the number of voltage drops in a circuit is always going to be equal to the amount of voltage you're feeding into it. If you're feeding 12 volts in, going all the way through that circuit, you're going to be dropping 12 volts all the way through it. You might drop 3 here, 2 here, you know, and then 5 here, whatever, and then 2 more over there. But always remember that. Are you going to be able to define that if I give you a fill-in-the-blank question? Burn it in, Nick, with your computer brain. Got that? All right. Remember the importance of voltage drop testing. Resistance is found in places we might overlook. Now, you know how to do voltage drop testing. We can easily pinpoint the location of unloaded resistance. Like for example, if I've got a problem with my alternator not charging the way it ought to, and everything else has been done, I might wanna go from the hot side of my battery to that big post on my alternator and see what's being lost. If something's being lost, I'm gonna clean terminals, right? Take the terminals off, shine them up, put them back on, get rid of as much voltage drop as I can. There's always gonna be a little voltage drop where there's a connection, but you can also do it on the ground side. You're basically gonna go from there to that side of the generator, like the body of the alternator. And if you got it on that side, you're gonna have the same issue, because current's the same throughout a circuit, remember that. Now this left headlight is dimmer than the right one, but the bulb is new. Now that's question 6. You're gonna start with question 6 because it's out of place in this slideshow, don't worry about it. The left headlight is dimmer than the right one, but the bulb is new. Where would you connect your voltmeter leads to do the first voltage drop test on this problem? The first voltage drop test on this problem. So in other words, that headlight beam is dimmer than that one, and it's not supposed to be. Obviously, you don't want one headlight dimmer than the other one. Where are you going to connect? The first test you're going to do. Fit it into the little box. And write it down. All right. Look at that, there's another question 6. Let's see what happens here. This voltmeter, write this out to the side in case you got this is an alternative question 6. This voltmeter is reading 3.8 volts when the starter's engaged. See the voltmeter? What needs to be done? This voltmeter is reading 3.8 when the starter's engaged. Right here. You notice it's connected to there and there. .8 volts. You're spinning it over. While you're spinning it over, you're reading that 3.8 volts right there. What do you need to do? What's the problem? The most likely problem, I should say. All right. Now, you can use voltage drop for your advantage. You got a fixed resistor right here, that's 5 volts. The engine controller takes advantage of voltage drop by reading the voltage after a fixed resistor to determine the resistance and temperature of the coolant temperature sensor. So it's basically got these in series, but it's got that one coming off that volt rail. It's basically going to, and if you unplug this, you're going to see the wide open thing. But most of the time, because they'll have a little current dropping resistor in there set up like they do, when you unplug this sensor, you're not going to see 5 volts, you'll see like 4.6. Now, a 3-wire sensor, if it's got a reference voltage going to it, it'll have 5 volts going to it. Remember, when you're doing a no start, if you turn it on and you don't hear the fuel pump, go first and see if your injectors are powered up. If your injectors are powered up, then you need to go see if you got 5 volts at your TP sensor or any other 3-wire sensor. If you don't, you'll have computer issues. If you check your 5-volt reference voltage at your computer and you see 12 volts, you probably got a bad computer ground somewhere, okay? All right. So a variable resistor provides the change in input. A negative temperature coefficient thermistor is what the engine coolant sensor is, because the hotter it gets, the less resistance it gets. That's the opposite of what you'd expect, all right? So dynamic rationality testing is done. You will scope your signal wire of your mass airflow circuit as well as the sensor and the engine controller. Since mass airflow voltage originates in the sensor, it's coming from the mass airflow sensor to here. A lower voltage measured in the PCM can be a great indicator. Like for example, you'll see what we're going over here. If I'm measuring between ground and here and I get 4 volts up there, and I measure between ground and here and I get 3.2 volts down here, what's my scan tool going to read? It's going to read 3.2, isn't it? I have seen a situation though, where you were reading voltage right here at a controller. It was a rear air suspension controller, and it actually was reading 12 volts right here, but if you looked at the scan tool, you'd read 8 volts, and it was throwing a code for that. That was a bad controller, okay? Parasitic draw testing is really important. Who's done one of those recently? Several of y'all, all right? Time consuming, yeah. Wait for modules to go to sleep, connected or disconnected circuits takes a lot of time. We do that sometimes. Well, you know, these people that, there was somebody long ago that, I mean, Chrysler used to teach this a long time ago, hey, you can measure voltage drop across the fuses. I showed somebody, didn't I show you this, Cal? Measure voltage drop across the fuses. Since there's gonna be a little voltage drop across any connection, if you go and measure voltage drop across all the fuses and you find one that's dropping the voltage, you have your meter set on the lowest setting, you'll maybe find it like that easier than any other way. We were actually fighting with this Buick that was killing the battery. I'm thinking that was a car your mama was driving one time. I could be wrong, but anyway, it was killing the battery, and she wanted it looked at. And there was 3 fuse panels on that dadgum thing, and one of them was under the back seat. And Zach was back there pulling fuses while I was watching our voltage. And finally, he pulled the radio fuse, and it was under the back seat of that Buick, and the draw went away. A lot of the times, the draw, not every time, a lot of times the draw will be the dadgum radio. Stupid radio just love to draw batteries. Not only be voltage drop in the circuit when the circuit's closed and current is flowing. You can eliminate the fuses with no voltage drop really quickly and narrow the circuit for light. You can also take your forward-looking infrared camera and shoot the panel if the car's been sitting there a while and see which one glows hot. All right, amperage. Amperage trace is taken with one of these, and we got one of those out here. The only thing I don't like about that is you actually got the little adapter to change it to a B and C for your scope, You got to find out what's really going on in the circuit right here. Now, scoping voltage and amperage on the same injector provides a view of the command as well as what happened. The opening of the injector panel is right here. That's whenever that little mechanical movement causes a deflection in that amperage thing. And you might notice that as soon as that injector closes and it's spraying fuel, the amperage in that thing comes up and it tops out right there. When it's released, you get a spike. It's about 50 volts usually. That's why you got to have your scope set up to read some fairly high voltage when you're looking at injectors. And you notice that whenever it releases that injector, the amp drops off for nothing. And that's pretty handy because you can tell if there's not a bump there on that one, then you got an injector that's not open. You got it? All right. Gather and apply knowledge. Take every opportunity to learn and improve. Don't be lazy. It's really easy. I don't know. I mean, ever since I've been teaching here, there's always some people that want to wander around the shop with their hands in their pockets and saying, I'm helping him. Don't go there. And people this one guy I put in a dealership was a really good mechanic. There was nothing he couldn't fix. But whenever the work was a little slack in the shop, and the guy that owned this dealership wanted to see him working on his GM's version of Electude, right? He wasn't doing it. He didn't think he'd see it important. He's wandering around the shop with his hands in his pockets, and so they let him go. And I think he's roofing houses or something now. But long and short of it is, if they can look at you and tell if you're driven, you know what I mean? If you're somebody that's going to be lazy, it's really something how fast. And when you're headed for the parts room, like we had, the parts department is like in a dealership or something, you need to be walking like you're late for an appointment. You know what I mean? Don't stroll along there, stop at the water cooler for a while and shoot the bull. Because the guy that's running the shop, he knows who's busting their rear end and who's lazy. You know what I'm saying? He knows who's fooling around cooking peanuts in a microwave when they ought to be working. He has all kinds of, different things you can do. There's no job that doesn't feel like you're in a rut sometimes. You ever feel like you're in a rut here? You do, don't you? Yeah. Now, when you have that motor out of that thing, you and Timothy gonna get that motor out this afternoon? Is it gonna be swinging? I may have y'all put that thing on a stand, and I may have you turn it over, and we may be able to pull those things off, look at those bearings, and see what they look like. Okay? So be prepared for that. We might want to prepare an engine stand for y'all to hang an engine on. Because, Timothy needs to get his hands dirty. Easy jobs don't pay well. Do they? They don't, do they? Easy jobs pay well? No. I mean, how many of you guys would like a $50,000 a year job where you walk around all day with a white coat and a clipboard and don't ever write anything down? There ain't no jobs like that.
If it was, boy, golly.
Yeah.
Well, I signed up at.
You've already signed up. You're going to do just fine. Don't you even worry about that. Nobody owes you anything you didn't earn. Do they?
Nope.
Yeah, you know what the old timers used to say? They say, do you have to back up to the boss man to get your paycheck? That's because you can't look him in the eye because you were there all week, I tell you what happened one time whenever I was, one summer I needed some work when I was a young teenager. And of course I drove around without a driver's license a lot of time too, but I went up there and I says, can y'all use anybody this summer to, help you build these houses and all? And I knew this guy and his son really good. They had a construction company, and he said, no, we don't need anybody. right now. And so the next day, I got up and I put on my work clothes and I went up there and went to work. Started, picking up 2x4s and moving stuff out and doing the stuff I needed to be done. And they just looked at me and sort of laughed, and at the end of the week, I got a paycheck. I went to work. They told me they didn't need me. I went to work anyway. I mean, you can't usually get along with that, But anyway, question 1: a 12-volt circuit is powering a bulb that's pulling 6 amps. What's the bulb's wattage? That was from the very first slide. A 12-volt circuit is powering a bulb that is pulling 6 amps. What's the bulb's wattage? Don't say it out loud, just write it down so we can mark it wrong when we're through here. All right. A 12-volt circuit is pulling 6 amps. What's the resistance of the load? A 12-volt circuit is pulling 6 amps. What's the resistance of the load? That was in the early slides, Got anything to do with math? Nick always aces it. Question 3: conventional versus electron theory. Conventional current flow theory says electrons flow which way? From what to what? You ready? Variable reluctant sensor produces what kind of signal? Draw it if you can't think of the name. This sensor on this right here, that's a variable reluctant sensor, by the way. Right there. Hall effect sensor produces what kind of signal? This is the Hall effect sensor right here. Right there. Who yawns when we're doing electrical tests? Kirchhoff's law refers to, don't say I didn't warn you. What is the amperage rating of this fuse? There was this guy one time that I worked with, and he was a real prankster. And it's not good to be a prankster, because I have known of people getting fired for playing pranks, so don't go there. But he was a smoker, and that was back when they didn't mind you smoking in the shop. And he had him a cigarette he was drawing on, and he saw this guy over here working in the dash, and he saw the guy didn't have the battery cable unhooked, and the guy had the instrument cluster out. And somehow or another he had a part of the dash off for the radio, and he went over, when that guy was looking away, he went over there and he blew cigarette smoke into the dash, and it started coming out through the, and that guy started unplugging stuff because he thought he shorted something out. That's not like something Timothy would do that. All right, voltage waveforms are captured using what kind of probe? You've learned this on Electube. he is a poster boy on electrode. He has blown every module out of the water all the way to the end on 2 courses already. Me and Adam were talking about him. He's a machine. All right. Amperage waveforms are captured using what kind of probe? Don't tell me you don't know.
Whoa.
I had one guy in here a while back that would put off his electrode until the very end, and then he would pull all-nighters for about a week. Why? You know, I mean, I understood he wanted to pass and all that kind of stuff, but wouldn't it make sense to pay as you go? It does, doesn't it, Tim? Tim? Yes, it
I don't
does.
have no answer for that.
Yeah. You don't have an answer for that. Pay as you go. All right, now let's back up and look at these.